6-7, using percent equations. Yesterday, when we looked at 6-5, we used something called the percent proportion, which you can see in blue. 3 is what percent of 4, and then we have 3 over 4 equals p over 100, and then we have the what number is 75% of 4, a over 4 equals 75 over 100. 3 is 75% of what number? 3 over b equals 75 over 100. We can streamline this process by doing some of the math in the problem before we substitute anything in, thus creating a shortcut. So yesterday, you would have seen 3 over 4 equals p over 100. Today, we're going to look at that and say p is equal to 3 over 4. If you were to type into a calculator 3 over 4, you would get 0.75. That's a decimal. We turn that decimal into a percent by moving the decimal point over 2 spaces, and you get 75%. Now, this works because if we take the percent proportion and we cross multiply just halfway, we end up with p is equal to 100 times 3/4. And when we found 3/4 as 0.75, we multiplied it by 100, and we get the percent of 75%. So we're doing some of the cross multiplication before we do any math. In the second example, what number is 75% of 4? We're going to rewrite that as a is equal to 0.75 times 4. I know that's true because 75 100ths, we can change that and look at that differently and say, hey, that's actually a decimal. We'll call it 0.75. And then since it's a divided by 4 equals 0.75, it's an equation we can solve by multiplying both sides by 4, which leaves us with what's in the third column. A is equal to 0.75 times 4. And then finally, the third example down, 3 is 75% of what number? Finding the base. We end up with b is equal to 3 divided by 0.75. So what I would like you to do as we do these examples today, I want you to try these problems today using this new method, the percent equations. You might find that you like it better. If after today you don't like solving problems using percent equations and you like the percent proportions from yesterday, that's fine. Go ahead and use those problems. So let's start with some examples. Remember, we need to read the example and then match it up to which form it looks like. The first number is find 42% of 150. What number is 42% of 150 is like the middle example. So we have a equals our percent as a decimal times the base. So a equals the percent as a decimal, which would be 0.42, times the base. A equals 0.42 times 150. And we multiply that out using a calculator. A is 63. So 63 is 42% of 150. Our next example is 49.5 is what percent of 132? We have to find the percent. That's just like the first one. So we're going to use the p equals 3 over 4 example. So p, because we're looking for a percent, is going to be the part over the base. So 49.5 over 132. I knew the 132 goes on the bottom because it's the base, because it's the number right after the 0. And when I type into a calculator, 49.5 divided by 132, I get p equals 0.375. That's a decimal. It's not a percent. This one requires a little bit of work, so we'll move the decimal point over 2 spaces. And we find that p is 37.5%, 37.5%. Moving on. 27 is 54% of what number? In this case, we're looking for the base, which is just like the last one. So b is equal to our part, whatever that number is, divided by the decimal form of the percent. B is equal to the part, 27, over the percent as a decimal, 0.54. And when you use a calculator to divide these out, the base ends up being 50. So 27 is 54% of 50. You will also see problems today that deal with discounts. The problem reads, how much will, it's a fictitious product. How much will this product cost with a 25% discount? The original price is $135. How much will this item cost with a 25% discount? The original price is $135. We know the percent. We know the base. We want to find the part. So we need to have A is equal to the percent as a decimal, 25%, times the original cost, $135. When we multiply those together, we find that the discount, A, is going to be $33.75. That's not the answer. In this case, we want to know how much the item will cost with a 25% discount. You have just calculated what the discount is. We now need to subtract our discount, $33.75, from $135. And you end up with $101.25. That's how much it will cost with the discount. We're also going to introduce you into some simple interest problems. The formula for interest is I equals PRT. On the right-hand side, we are told that I is the amount of money in interest. P is the principal amount of money that's either invested or borrowed. R is the interest rate. It's usually given as a percentage. And T is time. So with these problems, we read the problem through, and then we're going to fill in the information we know. So the problem reads, suppose you invested $1,200 at an annual rate of 6.5%. How long will it take until it earns $195? So let's go ahead and write in what each variable is going to be. So the interest is $195. The principal is $1,200. The rate is 6.5%. And the time we don't know, so we'll leave that as t. Before we go and substitute it into our equation, we need to turn the rate, the percent, into a decimal that we can work with. Because in our formula, I equals PRT, we don't use percents as percents. We need to have them as decimals. So 6.5% is 0.065. So now when we substitute in I equals PRT, $195 equals the principal, which is $1,200, times the rate, times t. We'll simplify a little bit, multiplying the 1,200 and the 0.065, and that leaves us with 78 times t. When I divide both sides by 78 to figure out the variable t, t equals 2.5. Very important to know what that 2.5 represents. Does it represent days, weeks, months, minutes? It represents years. And I know that it represents years because when we read the original problem, suppose you invested $1,200 at an annual rate of 6.5%. The word annual rate tells you that it is a yearly amount. Your homework is on page 301, problems 12 through 38, the evens.